I've seen a lot of interest about the Kong AI Gateway playing together with AWS Bedrock lately, and I thought that would be useful to showcase some capabilities they provide. Before doing that, let's take a look at the typical Kong AI Gateway deployment in AWS. As you can see in this diagram, we have the Kong Connect control plane responsible for managing your APIs connected to the data plane, component responsible for processing all the incoming requests sent by the consumers. Kong provides a plugin framework where each one of them is responsible for a specific functionality. As you can see, there are two main collections of plugins. On the left, the historical and regular API gateway plugins, implementing all sort of policies, including, for example, OIDC-based authentication processes with Cognito or observability with CloudWatch. At the same time, on the right, there's another plugin collection for AI-based use cases. For example, the AI rating team plugin implements policies like this based on number of tokens consumed by the requests. Or, as another example, the AI Semantic Cache plugin caches data based on semantics related to the responses coming from the LLM models. Talking about the LLMs, Kong AI Gateway supports out of the box a variety of infrastructures, including not just Amazon Bedrock, but also Mistral, Anthropic, OpenAI, etc. In order to deal with the embeddings, the gateway also supports vector databases. And then finally, Kong Gateway protects not just the LLM models, but also the upstream sources, including your applications, microservices, or services. One nice capability provided by the Kong Gateway is the possibility to combine both plugin collections. For example, you can use the key-off plugin to implement an API key-based security mechanism alongside the AI Semantic Caching plugin. The first use case I'm going to demo is related to the Semantic Cache plugin. The diagram shows how the plugin works. Consider request number one, where we don't have any caching data available. In step number one, the application sends a regular LLM request with a prompt inside of it. The first thing the Semantic Caching plugin does is reach out the embedding model to generate embeddings. And then uses in the step number three, these embeddings to run a VSS or vector similarity search against the vector database. Since the database doesn't have anything available, the plugin goes to Bedrock and sends the prompt. The response coming back from Bedrock is stored in the vector database. Now, in the request number two, where we do have some data cached, the request goes in a similar way. The plugin hits the embedding model and runs another VSS query. This time, the query is going to find something similar in the vector database available. Therefore, the cache plugin will be able to return to the application without having to send another request to Bedrock. Let's see all this working right now. All right then. So on your left, you see Connect control plane with three Kong routes defined. Let's check the Semantic Cache route first. The route has got two plugins configured, only one enabled though. The AI proxy plugin is responsible for connecting with Bedrock. To check the configuration, you're going to see the provider is defined as Bedrock, as expected, and then we're going to consume the Amazon Nova 1.0 LLM model. On your right, you see Insomnia, which is the tool we're going to use to send requests to the AI gateway. If you send the first request to it, we're going to get the request is going to be routed to Bedrock, and then Bedrock is going to reply back with the response. If you check the headers, we're going to see specific information regarding the latency times. Now let's get back to the route and enable the Semantic Cache plugin. We're supposed to see a different behavior now. To send the same request to the AI gateway this time, we're going to see specific new headers there. As you can see, there's a new X cache status header with miss value, meaning that the gateway was unable to find anything available in the vector database to satisfy the request. And then you had to go to Bedrock to get a response. However, if you send the same request to the AI gateway, this time we're going to get a hit, meaning that the gateway was able to find something available in the vector database to satisfy the request. If we send a similar prompt to the AI gateway, however, semantically speaking, similar to the first one, we are supposed to get a hit again. So that's the semantic cache plugin is all about. So different prompts, but semantically speaking, similar to each other, they're supposed to get exactly the same response. So that's it. In the next video, I'm going to demo two other use cases. The first one will be related to semantic routing. In the second one, I'm going to show how to use the request and response transformer plugins.